An array has two properties that allow for efficient access. It is contiguous in memory, that is, there are no gaps. Each member of the array is flush up against the next member. Also, it is uniform. Every member is exactly the same size. This means that the location of any member can be calculated by knowing three things: the address of the first member of the array, the size in bytes of each member of the array, and the index of the desired member. The index of the first member is 0. You can use other numbers to start the indexing, but it only makes the calculation of the addresses a little more complicated. When declaring an array, all you have to do is declare a block of memory. There are no boundaries or limits of any kind, so you need to make sure that you document the array that you declare. It's the only thing that will tell you how to address it. In the data segment, you can create arrays with initial values by using the normal declaratives with the values. You don't need to list separate values. You can repeat the same value by using the times prefix. And you can use combinations of declaratives to build a single array. This example declares an array of 5 32-bit integers with the initial values of 100, followed by 15 with the initial value of 200, and then 5 integers, each with its own initial value. Anything goes as long as you remember the two basics. The data is contiguous, and all the members are the same size. And of course, you can declare uninitialized arrays. In the BSS section, you can declare a block of any size and use it as an array. This example is an array of 32-bit integers, but remember, an array is nothing more than a block of memory. You can use it any way you want. This same block could be used as 10 32-bit integers, 20 16-bit integers, or simply an array of 40 bytes. Once you have space for an array declared, you need to know how to address members of that array. This statement assumes that the elements of the array are 8 bits in size, and the first member of the array is loaded into an 8-bit AL register. The assembler knows it's 8 bits not by the declaration, but by the fact that the AL register is used in the instruction. There is no offset, so it's the first member that's addressed. To address the next member of the array, you add 1 to the base address. For the next member, add 2, and so on. In this way, you can address every member of the array. In the same way, you can address the first member of an array of 16-bit numbers by using the address of the array. But to address the second member, you need to add 2 to the base address because each member of the array takes up 2 bytes. To address the third member, you need to add 2 more, which is an offset of 4. In general, to address any member of the array, you calculate the address by multiplying the size of an array member by the 0-based offset and adding that to the base address. For example, if you want to address the 6th member of an array of 32-bit integers, you multiply 5, which is the offset of the 6th member, by 4, which is the size in bytes of a 32-bit integer, and you get the number 20, which, when you add that to the base address, you get the address of the item you wanted. Now, there are several ways to do this. The next lesson has some information about more advanced techniques for addressing arrays.